Hi folks, Clay here with Claiborne LSAT, bringing you another LSAT setup, logic game setup video focused on the power of the decision tree method by which we play out as much as possible in advance before we even get to the questions. So we're going to be looking at prep test 30 here, game 4. Out of respect for LSAT's copyright, we're not going to put that on the video, not put the text on there or read it out in its entirety. We're just going to kind of dive right in and see what the game, how it challenges us, and see what the setup might need to look like. So if you look at this game, once you see the 7 toy truck models and the other details there, you'll probably notice that it is a sequencing game. So I don't know why that happened. Let's make our lines. Therefore, we want to set up kind of 7 columns, not just 7 spaces, but actual columns. And I'll show you why that is in a moment here. The reason we want to have columns is that we want to have room to fully draw out several possibilities, not just one of them, or not just kind of a master sketch. I think that's a mistake that sometimes is made on sequencing games. You want to leave yourself plenty of room for multiple scenarios, maybe as many as 10 of them, for how the game can play out. All right, so 1 through 7, thank you for bearing with me as I draw slowly on this Zoom whiteboard. Let's look at what's happening here. The first thing that we'll want to notice as we look at the rules, and I'm jumping right there because once you understand how the game works, this is really how the decision tree method works, is finding those best rules to start with. And there's nothing better than a block. There's nothing better than the rule that tells us M and G are right next to each other in that order. And you always do the same thing on strict sequencing when you have that. You just start that block at the far left and you gradually move it all the way to the right and you tease out all the possibilities. You're essentially just doing kind of a permutation. What are all the ways that this can happen if we have M and then G? Well, they tell us that S is always in number 4 and H then is always in 1 and 7. Well, it has to be in 7 in this case. So things are already falling into place. Now, of the remaining players, we only learn about F and J. So we're going to have to think about K as a floater here and essentially move around F and J to see what else takes place. Now, this is crucial. F and J is kind of a loose sequencing rule, right? It tells us that F is on a lower number than J. And often a student will just approach the game by simply noting that without kind of digging deeper. Well, in this particular case, we have limited options for how that could actually play out. In other words, F and J could be 3 and 5, they could be 3 and 6, they could be 5 and 6. So what I'm going to do is tease those out a little bit, but let's do this. If we say that F is in 3, we know that J could either be in 5 or 6 with K. We actually don't need to make that 2 game boards because that's really just a handle of the last 2 players, kind of toggling them either way. All right, so I'm going to copy the same spot for MG, put S and H in, and then do the only other way that F could fall into place. And of course, that has to be, if that's in 5, then J has to be 6. K would fall into place 3rd, and that's it, right? F cannot push any further to the right because it would push J off the end. We can't have players, elements just sort of falling off the end. That's as far as it can go. All right, now it might seem like a lot of possibilities. If we put M and G in number 1 and 2, and we already had a couple of different things that can happen, you might be thinking, well, isn't this just going to be too many possibilities as we move MG across? Probably not. We often find that other constraints intervene as we start to play out the possibilities. Most specifically in this case, that neither M nor G could ever be in number 4. So they're not going to be able to be 3, 4. They're not going to be able to be 4, 5 because S is there. So that limits us significantly all of a sudden. If we put them in 1 and 2, 2 and 3, with S and 4, we now have more flexibility for H. H actually really could be either 1 or 7. So we're going to test out both of those possibilities and then do similar things with F, J, K. If we put F here, J and K are interchangeable. If we put F here with all the other parameters the same, J is forced to be there, K would go there, because again, I'm just copying the other players down. And by the way, to make this quicker, you could also just draw down arrows there. I'm not going to do that here so that it's as clear as possible for you, but you could just draw a down arrow from S, from G, from M, from H, just to indicate, you know, those are in the same place. Or you could even put the little quotation marks. This doesn't change. All right, so in our decision tree process, we still want to lock in MG2 and 3 because we haven't explored all the possibilities that result if that block is 2 and 3. Most notably, we need to put H in 7 and move around FJ once again. F here, J and K interchangeable here, or F here, J must be there, K drops in 1. And again, the idea here is that the M, G, S, and H are all staying in place. All right, S stays here. We could really just draw one big down arrow for S because it's always in spot number 4. That wraps up M and G for 2 and 3. And we're going to have to move them all the way to 5 and 6, right? So that's making us getting closer to the end of the process as we see MG moving all the way to the right. All right, well, once again, H could be first or last. We're going to figure out what that means for F, J, and K. That'd be kind of a long handle to draw. So I'm just going to say if F is second, then that's J or K, that's K or J. And then same idea, but we move F to third, forcing J into last, K into second. Again, all of the others were in the same spots where they were already found. That is all that can happen if H is first. What about if it's last with MG here? H goes there, S here. Once again, we have to account for F, J, and K. So we'll do F with J and K a handle, or F with J there, K forced over here. S, M, G, and H. Finally, we're going to move M and G all the way over. Put S in place. That's going to force H to be first. So we'll figure out what can happen with F, J, and K. There's a lot of repetition in the process. And even though this is a high number of game boards, think of all you're learning about the behavior of this game as you go through the examples. That's the power that makes it worthwhile. And I want to talk a little bit more about those of you who might be skeptical about that. Because at this stage, you have to kind of wonder and say, well, we had to extend all the lines here. We had to think about, what do we have? 11, 12 different options. Is it really worth it? Now, I'm not going to argue with you if you say, well, 12 is probably too many. In fact, we often say that you pretty much want to cut it off at double digits. But I think this game is an excellent example of why it still might be worth it and of the power of the process. Even if it takes a while to do all this setup, check out the mastery of the game's possibilities that you have as a result. There's very little that you don't know at this point. The handles, the slashes, there's a little bit that can still vary. But frankly, this game is a little bit more complicated than some. It's not a high yield situation where in just a few game boards, we get all the possibilities. Here's another principle that I'd like you to think about at this point. It's something we often say to our students when they say, well, wow, that was a lot to draw right away. And the principle is this: it's draw now or draw later. Meaning, if you don't play out all these possibilities in advance, you're still going to have to play them out when you get to the conditional questions, because otherwise there will be simply way too many permutations and possibilities for how all of these elements might intersect with each other. So again, I'm not making an absolutely emphatic, unequivocal argument that you have to do these 12 game boards in advance. If you want to sort of note the possibilities about H1 and 7, put S in place, and then consider, you know, your block MG, and just be ready to draw that out when you get to the conditional questions, fine. I think that can be okay. But just keep in mind, you're going to draw now or you're going to draw later, and typically it's going to be about the same number of game boards in all. This game is a little bit more challenging than some strict sequencing, and is simply going to take more scribbling, more teasing out of the possibilities. If that's the case, why not get them all in advance and go into the questions fully equipped? That's our argument for the decision tree process. And we hope you'll see the power of it and embrace it so that it revolutionizes your approach to logic games like it has for many of our students.